This is SpaceTime, Series 27, Episode 150, for broadcast on the 13th of December 2024. Coming up on SpaceTime, a new study suggests Venus was never habitable. NASA's Mars Perseverance Rover now exploring the rim of Jezero Crater, and an ultra-cool quantum sensor used for the first time in space. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has shown that the planet Venus was never habitable. That's despite decades of speculation that the Earth's sister planet may once have been much more Earth-like than what it is today. After all, both these worlds are about the same size. They were formed in the same part of the solar system out of the same material and at the same time. But a new study looking at the chemical composition of the Venusian atmosphere suggests that the planet's interior is far too dry today for there ever to have been enough water for oceans to have existed on its surface. Instead, it now appears the planet has been a scorching hot, inhospitable world for its entire history. The new results, reported in the journal Nature Astronomy, have implications not just for understanding Earth's uniqueness, but also for the search for life on planets outside our solar system. See, while many exoplanets are Venus-like, the study suggests that astronomers should really be narrowing their focus to exoplanets which are far more Earth-like. From a distance, Venus and Earth look like siblings. But up close, Venus is far more like Earth's evil twin. It's covered in thick clouds of sulfuric acid, has a heavy carbon dioxide atmosphere, and surface temperatures close to 500 degrees Celsius, hot enough to melt lead. And even if you make it down to the surface pressure is 100 times atmospheric pressure at sea level on Earth. Now, it does rain on Venus, but it's acid rain. And there are snow caps on some of Venus's taller mountain ranges, but the snow is metallic. All in all, if Venus is Earth's sister planet, then it really truly is a twisted sister. Yet despite all these extreme conditions, for decades astronomers have been investigating whether Venus once had liquid oceans capable of supporting life, or whether some mysterious form of aerial life could exist in its thick clouds nowadays. The study's lead author, Teresa Constantino from Cambridge University, says scientists won't know for sure whether Venus can or had supported life until we actually send probes there. That won't be till the end of the decade. But given it likely never had oceans, it's hard to imagine Venus ever having supported Earth-like life, which requires liquid water. When searching for life elsewhere in our galaxy, astronomers search for planets orbiting within their host star's habitable zones. That's an area where it's not too hot and not too cold but just right, a so-called Goldilocks zone, for water to exist on a planet's surface in a liquid form. Now, in our solar system, there are 3 planets within the Sun's habitable zone: Venus, Earth and Mars. But Constantino says Venus and Mars provide a powerful limit on where this habitable zone actually lies around a star. See, only the Earth is habitable. Even the Earth's moon lacks the conditions for habitability. Currently, there are 2 primary hypotheses to try and explain how conditions on Venus may have evolved since its formation 4.6 billion years ago. The first is that conditions on Venus's surface were once temperate enough to support liquid water. But a runaway greenhouse effect caused by widespread volcanic activity caused the planet to get hotter and hotter, eventually evaporating the water. The second is that Venus was born hot and liquid water was never really able to condense onto the surface. Now, both of these hypotheses are based on climate models, but Constantino and colleagues wanted to take a different approach based on observations of Venus's current atmospheric chemistry. To keep the Venusian atmosphere stable, then any chemicals being removed from that atmosphere should also be getting restored to it, since the planet's interior and exterior are in constant chemical communication with each other. The researchers calculated the present destruction rate of water, carbon dioxide and carbonyl sulfide molecules in Venus's atmosphere, which must be restored by volcanic gases to keep the atmosphere stable. And volcanism, through its supply of gases to the atmosphere, provides a window into the interior of rocky terrestrial worlds like Venus. As magma rises from the mantle towards the surface, it releases gases from the deeper portions of the planet. Now, on Earth, volcanic eruptions are mostly steam. That's due to our planet's water-rich interior. But based on the composition of the volcanic gases necessary to sustain the Venusian atmosphere, the authors found that volcanic gases on Venus are at most just 6% water. These dry eruptions suggest that Venus's interior, the source of the magma that releases gases into the atmosphere, must also be dehydrated. At the end of this decade, NASA's Da Vinci mission will be able to test and confirm whether Venus has always been a dry, inhospitable planet, with a series of flybys and a probe which will descend through the atmosphere down to the surface. The results could help astronomers better narrow their focus when searching for exoplanets that could support life in orbit around other stars in our galaxy. Constantino says if Venus were habitable in the past, it would mean other planets we've already found might also be habitable. Instruments like the James Webb Space Telescope are best at studying atmospheres of planets close to the host stars like Venus is to the Sun. But if Venus was never habitable, then it makes Venus-like planets elsewhere less likely candidates for the habitable conditions necessary for life. This is SpaceTime. Still to come, NASA's Mars Perseverance Rover finally exploring the rim of Jezero Crater, and ultra-cool quantum sensors demonstrated in space for the first time. All that and more still to come on SpaceTime. Well, after a long and difficult journey, NASA's Mars Perseverance Rover has finally reached the rim of Jezero Crater. Right now, the rover's taking a close-up look at Picotquino. Mission managers hope to investigate the geological history recorded in this roughly 200-metre-long region of exposed rock outcrop. Scientists say these rocks may reveal clues about ancient geological processes on Mars, including those that predate or are related to the violent impact that formed Jezero Crater in the first place. The car-sized 6-wheeled robotic rover has been studying a number of unusual rock outcrop ridges during its long and difficult ascent to the crater rim. The journey up to the rim has been steep and dangerous, with numerous sandy basins making the climb up from the dried-up riverbed delta floor very slippery. Now on the rim, scientists want to characterise the compositional diversity and structure of these exposed rocks. After paralleling Picotquino for about 70 metres to the south last week, mission managers planned a close-up approach over the weekend that positioned the rover at the far southeastern extent of the ridge. Prior to the 107-metre-long drive, scientists planned 2 days of targeted remote sensing, using both Mastcam-Z and SuperCam to investigate local regolith and conduct long-distance imaging of a steep scarp and a 20-metre-wide crater to the northwest. The successful approach drive allowed scientists to focus on assessing outcrops amenable for proximity science and repositioning the rover for upcoming abrasion activities. Following the abrasion test at Picotquino, the rover will be hitting the road again on its way to its next science stop at Witch Hazel Hill. Orbital views of Witch Hazel Hill suggest that this area may contain layered light-toned bedrock, and that rock could likely have recorded important information about the planet's ancient climate. But prior to arriving at Witch Hazel Hill, the rover plans to pass through a high point known as Lookout Hill, and that will afford mission scientists incredible views looking back into the crater, as well as getting a glimpse westwards of the wild Martian terrain far beyond Jezero. This is SpaceTime. Still to come, NASA demonstrates its ultra-cool quantum sensor for the first time in space, and later in the science report, a new study warns that permafrost thawing due to climate change may increase the risk of wildfires in both the Arctic and subarctic regions. All that and more still to come on SpaceTime. NASA's Cold Atom Lab, a first-of-its-kind facility aboard the International Space Station, has taken another step towards revolutionising how quantum science can be used in space. Members of the science team were able to measure subtle vibrations of the space station with one of the lab's onboard tools, the first time ultra-cold atoms have been employed to detect changes in the surrounding environment in space. The study, reported in the journal Nature Communications, marked the longest demonstration of the wave-like nature of atoms in microgravity. The Cold Atom Lab science team made their measurements using a quantum tool called the Cold Atom Interferometer, which can precisely measure gravity, magnetic fields and other forces. Scientists and engineers on Earth use this tool to study the fundamental nature of gravity and advanced technologies that aid aircraft and shipping navigation. So physicists have been eager to apply atom interferometry to space because microgravity there allows longer measurement times and greater instrument sensitivity. Cold Atom Lab project scientist Jason Williams from NASA's Jet Propulsion Laboratory in Pasadena, California, says that reaching this milestone was incredibly challenging and success was never a given. He says that space-based sensors can measure gravity with high precision and have a wide range of potential applications. They could reveal the composition of planets and moons in our solar system because different materials have different densities, and that creates subtle variations in gravitational fields. Now, this type of measurement is already being performed by the joint American-German collaboration GRACE-FO. That stands for Gravity Recovery and Climate Experiment Follow-On. It detects slight changes in gravity in order to track the movement of water and ice on the Earth. An atom interferometer could provide additional precision and stability, revealing more details about surface mass changes. Precise measurements of gravity could also offer new insights into the nature of dark matter and dark energy. These are two of the biggest cosmological mysteries facing science today. Atom interferometry could also be used to test Einstein's theory of general relativity in new ways. And that's the basic theory explaining the large-scale structure of the universe. You see, we know there are aspects of general relativity theory which we don't understand correctly, at least not yet, and this new technology could help fill in those gaps, providing a more complete picture of the reality we inhabit. The Cold Atom Lab's about the size of a bar fridge. It was launched to the International Space Station with the goal of advancing quantum science by putting a long-term facility into microgravity in low Earth orbit. The lab cools atoms down to almost absolute zero, that's minus 273 degrees Celsius. Now, at this temperature, some atoms can form what are known as Bose-Einstein condensates. That's a state of matter in which all the atoms essentially share the same quantum identity. In other words, they act like one giant single atom. As a result, some of the atoms' typically microscopic quantum properties become macroscopic, making them easier to study. Quantum properties include some really weird science, like sometimes acting like particles and sometimes acting like waves. This particle-wave duality's always intrigued scientists. Trouble is, scientists don't know how these building blocks of all matter can transition between different physical behaviours. But they're using quantum technology like what's available with the Cold Atom Lab on the ISS to seek the answers. In microgravity, Bose-Einstein condensates can reach colder temperatures and exist for longer, thereby giving scientists more opportunities to study them. Due to its wave-like behaviour, a single atom can simultaneously travel two physically separate paths. Now, if gravity or other forces are acting on those waves, scientists can measure that influence by observing how the waves recombine and interact. This report from NASA TV.
Have you ever wanted to be in two places at once? It's not something we can do, but atoms can. How is this possible? Well, atoms are the building blocks that make up everything we can see in the universe. But when we look closely at atoms, they exhibit some pretty mysterious behaviors that we don't see at large scales. Sometimes atoms act like solid particles, or a lot like billiard balls, bouncing off each other and other objects. But sometimes atoms act like waves, just like waves on the ocean. So a single atom can travel through two passages at the same time. That's how an atom can be in two places at once. And when these atoms interact, they can scatter off each other, pass through each other completely, or combine. The study of these behaviors is called quantum science. This field has changed humanity's understanding of the very nature of the physical world. It has also led to the development of all kinds of technologies, including cell phones, computers, MRI machines, and even GPS. But Earth's gravity makes it tough to study these little atoms for very long. So, NASA built a quantum science laboratory in space. They named it the Cold Atom Lab. It operates inside the International Space Station, but it's run remotely by scientists back on Earth at NASA's Jet Propulsion Laboratory in Southern California. Inside the Cold Atom Lab, atoms are cooled to less than 1/1000th of a degree above absolute zero. That's colder than the coldest matter ever found in the natural universe. Because cold atoms are almost motionless, it's easier to look closely at how they behave. And did you know a whole bunch of cold atoms can also start to behave like one big quantum wave? This is called a Bose-Einstein condensate. It is a fifth state of matter, distinct from solids, liquids, gases, or plasmas. It makes quantum behaviors bigger and easier to study. Without Earth's gravity getting in the way, scientists can study atoms longer and open up new avenues of quantum exploration. NASA's Cold Atom Lab is the first quantum science facility in Earth's orbit, and it's helping us answer new questions about the quantum nature of the world around us. What we learned from the Cold Atom Lab could one day be used to study the composition of other planets and moons from orbit. They could also improve space navigation or help us understand cosmic mysteries like dark matter and dark energy. Who knows what we may discover next? Quantum science could change our understanding of the universe, one cold atom at a time.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has warned that permafrost thawing due to climate change could lead to an increase in wildfires in Arctic and subarctic regions. The warnings reported in the journal Nature Communications show that an increase in wildfires over permafrost regions may lead to changes in total terrestrial carbon uptake. Permafrost is ground that normally remains permanently frozen, but it's been shown to be thawing due to global warming temperature increases. That's leading to changes in soil moisture levels, and that may alter the likelihood of wildfires. The authors used a climate model which simulates the Earth's climate system to analyse 50 different climate situations under both historical and projected future emission scenarios for the period 1850 to 2100. Their model projects a notable increase in permafrost thawing and a rapid decrease in soil moisture, especially in regions such as Siberia and Canada between the mid to late 21st century compared to historical records. This abrupt decline in soil moisture is associated with an increase in surface air temperature and a decrease in relative humidity, further exacerbating the effects of rising temperatures, which could be associated with a projected intensification of wildfires, especially in high-latitude regions. Scientists have discovered a new way to use DNA to catch criminals. The pioneering new DNA forensic technique, reported in the journal Forensic Science International Genetics, looked for a reliable method to measure a suspect's individual level of natural shedding of skin and other cells to add to and compare with evidence collected at crime scenes. Using a novel technique of cell staining developed at Flinders University, forensic science experts have tested 100 people to confirm how people shed varying levels of touch DNA from very low to very high. Of course, all this assumes the DNA isn't second-party transfer or deliberately planted there by corrupt cops. A new study warns that many of the Earth's oldest, largest and most experienced animals are being quite literally wiped off the planet by human activity. The findings, reported in the journal Science, shows that poaching, trophy hunting, culling and harvesting often targeted the largest animals in a group because they have the largest antlers or horns or tusks. And this, coupled with pressures from habitat loss, disease and extreme climate events, can lead to a loss of large and old animals. From sponges and sharks to elephants and lions, there's a wide range of species where older animals are being overexploited. But the authors say this depletion of the oldest animals continues to be an underappreciated issue for natural resource management. They're calling for dedicated policy directives, political motivation and careful management in order to preserve these vital elders. New images have emerged of what's reported to be the famed Loch Ness Monster. One involves a sonar reading of a large object lurking in the depth of around 96 metres. The other is a series of pictures of the mythical creature taken years ago but only just released. Tim Mendham from Australian Skeptics says they join the thousands of other images of the famous beastie, which all appear to have the one thing in common.
I love Nessie. Been there 3 times trying to find Nessie. Loch Ness Monster we're talking about in Scotland. Beautiful location. Very much worth visiting. Haven't seen a monster. There's a couple of examples of sightings, and I use that advisedly, in quotes, etc., of the Loch Ness Monster. And one of them was a sonar reading with someone who went out with the wonderful name of Sean Sloggy.
This is the seasoned Loch Ness skipper?
Yes, seasoned. He's only about in his early 30s.
Does that mean he's an old salt?
Haha. He supposedly saw this sonar thing of something big, never seen anything like it. He said, the sort of thing that leaves you speechless. I'm sure it is. He went back in, he talked to someone else, another seasoned pilot, maritime pilot, is all of 29. They went back out to see if it was there, and it wasn't there anymore. So therefore, it must have been alive, or it must have been a weird sonar effect. Could be heat or anything, or coolness, or whatever you can sort of find on a sonar screen. The second one was a bunch of photographs that someone had kept for a while and finally released them, having been too embarrassed to release them earlier, which I understand. You release something like that, you get a bit of ridicule from the skeptics, no less. The trouble is, the sonar thing and the photos that have been released are really poor.
That's always the case, isn't it? It's never a really sharp, clear picture or other images taken from various angles. It's always a blob.
Yes. I mean, those that are very well focused are fakes, and they're easy to spot by and large. So something which is vague.
Like the surgeon's picture.
Yeah, well, the surgeon's picture convinced people for about 70 years that it was real until someone finally... And, I kept saying, you look at the surgeon's photo, those ripples coming off that thing are too big for something in a big loch. That's right. It's like a tidal wave. They're little ripples in a pond and, for a small object. And I kept saying that, and they finally agreed with me that it was a fake. And it was a small thing about the size of a toy submarine. In fact, it was a toy submarine, I believe. So that photo, the famous photo, you've seen it on the front of every book, every Loch Ness story, etc. The black shape with a big neck coming out was around for about 20 years until one of the people involved in it said it's a fake. There's a group called the Official Loch Ness Monster Fan Club, has an online register of about 1,000 sightings of Nessie. And you see with 1,000 sightings that are listed and all the ones that aren't listed really should have something better than just some fuzzy photograph that you really can't see anything and someone points to you, there it is, and you stare at it and say, where? And all the explanations for what it might be, a plesiosaur, you've got to have a mate.
You really need a colony to survive.
You need at least two, and then the kids, right? And you see a lot of these things out there, this loch, which is it's long, but it's not that long. You see a family of these things wandering up and down the water, etc. They can't hide, really. It's not for very long, and not when you have to have a lot of them, and they're breeding like crazy. So one is not enough. One's not going to last very long. So it's the same for Bigfoot and Yetis and all sorts of these things. You've got to have families. Otherwise, they're only going to be one of them, and they're not going to live forever. But anyway, bad photos, if you get a bit of evidence, like a photo of something, and you can rate it at 2 out of 10, having two out of 10 bits of evidence does not make a 4. It makes 2 times 2 out of 10. A lot of bad evidence is still bad evidence, regardless of how many you have. You're looking for the good evidence. We haven't seen anything like that at all from Loch Ness or for a lot of the cryptids that are sort of claimed around. Love to see it. Would love it. Show me some good evidence rather than some, perhaps so-so evidence. I'd love there to be a Loch Ness.
I want there to be a Loch Ness Monster. I want there to be a Bigfoot, but yeah.
There's lots of lochs in Scotland which have their own monster, of course. I think Loch Lomond has one. Quite a few lochs all around the place.
Lake monsters are common around the world.
Everywhere. There's a Lake Champlain in Canada. There's Ogopogo in the US. We have our own. We have bunyips, of course, in Australia, and all sorts of things like that.
Don't forget Yetis.
Don't forget Yetis. But every country in the world has some sort of big ape-like, man-like creature.
Yeti Goldberg, she's just on the view, but
including Singapore, which is about as big as a postage stamp.
Yeah, lives in the park somewhere, doesn't it?
It lives in a small park in the middle of Singapore. Apparently it doesn't anymore. It's disappeared. What a shame. But, it is a strange phenomenon. You go around to all of America, you think Bigfoot is being in a forest or something like that up in the northwest, Oregon, Washington State. It's supposedly big feet all over the US, in desert states, and you name it. So you think...
I've watched Finding Bigfoot. I'm familiar with this hypothesis.
That's when they go out in the night and they hear a howling sound.
They never quite get there in time.
No, they was rush up and said, we just missed it.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.